So those at home, those in class right now are writing down these notes things that you see here for the ambiguous case. You should look at the calendar and watch the video I provided about what the problem is for the day. All right. So stop this video, go do that first, and then come back to this. Otherwise, you'll be a little cloudy about what's happening here. Now to you guys in class live. She talked about, let me make sure I find my pen here, about there being a chance that you don't even have a triangle when you're given ASS. She talked about, hey, watch that previous video if a triangle even exists. I didn't want to go over that because there's actually an easy way to do this and circumvent the scenario. And what happens when you don't have a triangle, you will just get a math error. And that's all you need to know. They gave you information that doesn't make a triangle. Here's what actually happens. Remember, it's this angle that they gave you, like right here. So let's call this angle B. So they give you angle B. I'm going to make up something. I'm just going to make up something for the video and say this is like 70 degrees. They didn't really give that good credit there. 70 degrees is probably opened a little bit more. And then let's say this side measure right here is like 35 feet. And then let's say this side opposite is 3 feet. Well, that's kind of ridiculous, right? I mean, think about an angle measure that's 70 degrees and this arm is super long. 3 feet actually would only be like hanging down this far compared to what 35 feet is. Does that complete the enclosure? Yes or no? No, you don't ever have to know that. What's going to happen is you're going to try to solve this triangle and try to find this angle over here in this corner. That angle can't exist because this enclosure never happens. So mathematically, you will get a math error and you will just say, stop, there is no triangle. This information is bogus. So that is why you really don't need to know that. All you have to do is do that one step, which is really not a lot of work. Okay, but then it turns into the problem. And hopefully you at least got something about what the lady said about how there could be two triangles. Um, so the next thing that will happen is you try to solve and you get an answer. Well, automatically, what you should try to do is find out, is there a second triangle? You should do the supplement thing. You should draw a completely different triangle that looks obtuse and see if the supplement creates a second triangle. And you will find that in some cases it does not. So therefore, there isn't a second triangle. You cross it off and you go back to the first triangle and solve it. Or, like in the video, two examples, you do have two triangles. You have to solve those two separately as two completely separate different problems in one piece of information, one question. And I will put that for the two triangles. One is acute. So you're given like this angle B, side A, and side B. And then this angle is acute that you find. And then the second triangle is an obtuse triangle. And you are going to draw them both. Still, you were given this angle, this side, and this side, except this angle is obtuse. And the relationship between these two is they are supplements. And that's as simple as I can make it. Otherwise, it can be real complicated. There's a whole bunch of different scenarios that we could list out that could happen. That she talked about one of them. This simplifies and synthesizes the situation as best as possible. Okay, so you will draw both and draw a line and treat those as two different questions, right? And that's how it works. Okay, so in your notes, you do have this example given. And then I created two more that you're going to have to scratch somewhere else. Maybe the second one right below this one, so try to save some room. And then the third example, maybe throw in the blank back sheet. Remember we were on the blank back sheet, right, guys? All right, so just make sure we got that going on. Okay, so looking at this, here's your first information. First thing you do is draw the triangle, all right? And I'll try to give 62 degrees justice, but it doesn't really matter. Actually, I couldn't care less. I'm going to just make my triangle like that classic pumpkin eye, just boop, 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 get my three sides because the big deal is getting the sides and the angles opposite of each other. All right, and then I always like putting B here, the other side, so I have that arm there so I can really see ASS. All right, so again, this is your issue. When you see this is the case that's given, naughty word, red light in your brain, I have something different I have to do. All right, all the other ones, SAS, SSS, you're just going to get one answer, one triangle, and it's not going to be a problem. Okay, so next thing. Hopefully, you know, as simple as it gets, that I have to find angle B. It's the only thing I can find right now because it's opposite that side measure. So you just go along your business, try to find angle B from our um, Math 2 days. Sine of B over B equals sine of A given over A. And again, one more reason why law of sines works. How many unknowns are there? How many unknowns are there? Tell me. One. All right. So I have one unknown. So that's why the law of sines is going to be very solvable. All right. But then go ahead and grab your calculator out. I think I did calculate these. Understand how this is slightly different than yesterday. This is the first time in this chapter. It's only day 2, though. So let's not overdo it. That you have to inverse sine in order to find that answer. So for your work purposes, by the way, this is all you have to have written. This, and then I assume that you know how to type on your calculator. You know, I assume you know how to cross that 12 across and multiply, and then assume you know how to type that in and then inverse sign it. So, you know, do be aware that minimal on the work is fine. Oh, I think I have it. I'm going to cheat and be lazy here. Maybe. Yeah, maybe it's too far away. Oh, there it is. Wasn't it 12 sine 62? Oh, shoot, I went too fast. Now my calculator's all. So this is always what I do. I hit 12 sine 62. Make sure your calculator's in what, by the way? Every day in degrees, in case some friend of yours borrows it and the teacher in that class deletes your memory. Then it goes back to radians. And then divide that by 15. So get the numerator done first, then divide, then inverse sign. If the inverse sign that ratio, in order to get 44.94. Let's just say 44.9. So what does this mean? It means I have this first triangle. It exists. And I need to continue and solve for everything else. I have to solve for angle C and side C. But wait, I want to see, is there a second triangle? So I draw a line in the sand, and then I draw an obtuse version of this triangle. Believe me, this is going to be easier in the long run than other possibilities that you might have to do. Okay, other things that you have to think about. Do understand 62 is still here, 12 is still here. And then she did say something about how this is impossible to have a second triangle when A is longer than that arm. Don't care. You just make sure you understand you do this check. What's the relationship between these two angles? What are they? Starts with an S. Supplements. So you already said it. So I take 180 minus that and then check it in this other triangle. And I'll show you what goes wrong with this immediately. 180 minus answer. Can't say I'm going too fast. I'm actually trying to find an answer button. There you go. And that's 135.1. So now let's look at what's fundamentally wrong with this. 135.1 degrees. What's wrong with these two angles in a triangle? They are greater than what? 180. This would have to be a negative angle measure. What? That is not, we're not dealing with trigonometry that we dealt with in chapter 5, 6, and 4, and whatever. So this is not a second triangle. There is no second triangle. Cross it off, go back to the other triangle and solve for it. So now I'm going to go back to this and do angle C. That's just 180 minus. I never want to have you write that down. Just go ahead and do 180 minus these two. Can someone tell me what that angle measure is? Be a pal. I'll wait for you. What's 180 minus 62 minus 44.9? I can almost figure that out, but it would be nice if someone answered for me. Huh? 73.1. Does anyone agree with that? Thank you. And then once this is 73.1, I guess I like changing the colors so you know what you found, what's different. And then I'll stay green with this one. To find side C, it's law of sines now. So ultimately, this is not different than what you did yesterday, this example, because something difficult didn't happen. You didn't end up with two cases, but you do have to go through it. And then use your given sine of 62 over 15. All right. And then this one's pretty easy. It's 15 sine 73.1 divided by sine 62. Anyone? 16? It should be bigger than 15, right? So I kind of like that answer because 15 is opposite 62, 16.3 opposite 73.1. At least it feels good. Anyone else agree with that, though? Yes, got a couple of head shakes there. So did you hear what I went through on that? It's actually a good thing to go through in your mind. Does it make sense, your answer? All right, and then I'll circle the three answers that we found in this question so I know where we're looking. So notice my work there. For you, as purposes for you, this is minimum. This is what I need to see, and this is all I need to see. All right? I don't even need to see that middle one that I erased there, but I was just teaching on that point. So at least show the trig where things came from. All right? I just thought I'd bring that back, though. Okay? All right. Now, this is the one where hopefully you have room for this one because I kind of gave away what happens with this, but I'll cut it off. This one you do not have in your notes, but try to sync it right below that one right on that page right there. Try to make a spot for it. I'll tell you exactly what's happening with this one here shortly. Actually, look at the lengths here, but never guess. Never guess. So as you're drawing this, same old, I'm going to try to give 55 some credit. I'm going to try to give it like it's probably open about that far. Oh no, and then it's 55 degrees, 40 minutes. How many minutes are there in a degree? How many minutes are there in a degree? 60. So when we type this on the calculator, it's going to be 40 over 60. Remember when we did that? Then when we're calculating? Okay, and then look at this. This is 25.1. This is A. And then this is 8.94. Do you think that's going to be long enough when this one's 25? If I actually got a ruler and did 25 centimeters and 8 centimeters and got a protractor, this would not complete the enclosure. But I don't want you to think about that. I just want you to do this. Just connect it. Just tell yourself it's 8.94 and then continue on and try to solve. And that's really what needs to happen. And then that makes your life easy, makes you have less things to think about. Next thing, ASS, siren. Naughty word, tougher math thing to do, possibly. Actually, this one's easier. When we try to find angle A, sine of angle A over, sorry, I got a little too zealous on that one, 25.1. So 25.1 is opposite A, and that equals, I don't like where that equal sign is now. Come on. Pen. Equals. Okay, here's what we're going to type on this. Pen's going away from me again. 55 plus 44. Oh, I'm sorry, 40. I don't know where that 4 came from. Over 60. So that's old school chapter 1, remembering how to deal with that kind of calculation. Divided by 8.94. Okay, now I am going to go ahead and type this real quick on the calculator because I do want this number. So sine of 55 plus 40 over 60. Sine of 55 plus 40 divided by 60. Sorry, I forgot to hit multiply. Enter. Then I'm going to times that by, what did I have to times that by? 25.1 times 25.1. Watch. I'm just going to press enter. My numerator is done now. Now I'm going to divide that by 8.94. So I want you to see why this is bad. 2.32, let's just say. There is a simple, what was that, 2 point what? 32? Sorry, my mind already forgot it. This is why the calculator gives you an error. Just think of SOHCAHTOA. Sine of an angle equals what over what? What side over what side? So opposite over hypotenuse equals 2.3. That means the opposite side is what compared to the hypotenuse? Bigger. That is why this is going to be an error as well mathematically when you go to the calculator. You don't have to care about any of that. When you get an error, what do you say about this information? No triangle exists with this information. It's bogus. And it really is because of that not completing the enclosure thing. I could give you a protractor and give you a side that's this length and that length. You would not be able to complete the enclosure and complete the triangle. Don't have to care about it. All right. Then this last example, maybe go to your back sheets. That's where I did put this one. Notice the angle measure 55.3, pretty close to the last one. I think it was 55.40 minutes. So kind of a bigger angle. Notice the thing that she did say in the video, but I don't want to have you have to memorize a bunch of stuff. The first triangle that you do draw, though, is definitely, do you have the acute triangle? Here's 55. Here's 22.8 directly across from it. And I always like making this the arm so that I see that this is ASS. And then this would have to be angle C up here. So it's really a smart thing to see the ASS. I always draw my triangles like that and try to put my first information in the left corner just because of this ambiguous case. When that happens, I really see ASS and know that I have a situation I got to be worried about a little bit more. Not to scare you about it, but that's what the case is. Same old, same old. It's really not a tough start. That's why it doesn't take long. We'll put the minimum of as far as what we have to have on the paper. And then angle B equals. There's that computer just doing whatever it wants to do. So I'm showing the minimum, at least what I need to see from you, then hoping you can do the cross multiplying and all that other stuff. Okay, fine. For completion of this, it's 24.9. Let me slide this over. 24.9 times, you're certainly better than me at this. It's hard for me to type on this thing. 55.3. Again, double check that you're in degrees. I always press enter. So I don't have to worry about not closing my parentheses or whatever. And then divide that by 22.8. That's what mathematically would happen in this. Okay, that number is less than 1, so I know I'm going to get an answer. Okay, but that's what sine of B equals. So then I second sign, and I already showed that in the notes. So understand. Oh, shucks. I screwed up. Second quit. Okay. So now I have to inverse sign, and I have to type that in. Oh, I'm so mad at myself. 0.8976. At this point, it's enough. I'll probably get it not close enough. 63.9. Okay. So that is 63.9, that angle measure. We do have one triangle. Now it's time to draw a line in the sand. Before you continue, do I have triangle 2? Question mark. Triangle 2 would have the same given information, but be obtuse. This is on you to do this. This is still 55.3. That is still angle A. This is still side A, but swung over to the other side. And this is side B. One more time. What is the relationship between these two angles? They are what? Supplements. So all I have to do is find out, does the supplement create a different triangle? 180 minus 63.9 is what? Ooh, we got somebody. What is it? So here's the thing. 116.1 leaves me enough angle measure for that third sliver. And therefore, there is a second unique obtuse triangle with the same given information. It's It's all you got to do. It's really not that hard. But students, I don't know why they get this jumbled up in their head. So, all right. So, what is that third angle? Probably going to go to triangle 2 and finish it off. And look at what I did with the A's and the B's. What did I put on them? I put 2's on them. So, when I solve the second triangle, I have to say angle B2 is 116.1 degrees because it does create angle C2, which is what's 180 minus these two? Could someone do that for me real quick? It's small, 8.6. Thanks for helping me out here today. I do mean that. So that means that is the reason why there's a second triangle. There is enough for that C2. And then if you want to just continue with this one, fine. Since that's 8.6 up here, then finish this off and then go back to the first triangle. Maybe to keep your thoughts here focused on this one. This is why I want to limit how much you type. As long as you know what you're typing, you're good on this. Okay, so that one is 22.8 times sine 8.6 divided by sine 55.3. We'll get that shortly. Anyone? Anyone type it? Any typers in here? You guys aren't really helping me out here today. It's weird. Were you scared by the other person in here? What's going on? Okay. No one's talking to me at all. Maybe I did something. Maybe my Star Wars shirt's offensive. 4.1. Now, what do you think C1 is going to be, bigger or smaller? What do you think C1 is going to be, bigger or smaller? Bigger. Look at it. It's longer, right? It's opposite a bigger angle measure. So now I'm going to go back to here and find C, angle C. I guess we have to call these ones now because this is from the first triangle. So angle B1 and C1. Angle C1 is just 180 minus. I think I remember it being 70 something. What's 180 minus these two? Oh, 60.8. My bad. I was thinking of something else then. You're right. Those are right around, yeah, that should be right around. They're close to all right around 60 degrees. So, yeah. And then for this C, lowercase c1, it's sine of 60.8 divided by c1 equals, go back to your original, sine of 55.3 over 22.8. All right. Crisscross multiply and then get what C1 is. So circle, circle, and then C1, I'll put the answer over here. That's actually a real easy one. 20 times sine 60.8 divided by sine 55.3. What'd you get, Isabel? 24 on the dot, 0.0? Really? Anyone else? Be nice to have someone verify. 0.2? Who said that? What did you get, Natalie? Nothing? Oh, 0.2? Okay. No big deal. I lost where I was at, though. Where did I go? Where am I? What's happening? Oh, it's all the way in the bottom. That's right. Sorry, those in the video. Oh, and I'm really showing my Star Wars shirt off here in the video. Did you retype it and get 0.2? No? All right. Okay, so hopefully the situation is established, all right, that we got to deal with.